Welcome to this video. I am Physics and today we are going to be going over motion graphs. So the first graph we're going to be looking at is a displacement time graph, where as you can see the y-axis is displacement and the x-axis is time. So I'm going to be labeling each of the lines and going to be talking about them. So number 1, which is the slope going up. If you were to calculate the gradient of that, it would be displacement divided by time, and that will equal velocity. So therefore, as it is a straight line as well, this will be a constant velocity. The second line is a horizontal line, where the displacement is going to stay the same. That means that it is not moving. So in other words, it is stationary. And the third line is a line going downwards. And so as it is the same thing as, if you were to find the gradient, it will be the same as displacement over time. But as it is going downwards, it will be a constant negative velocity. But as you can see, that the gradient, the slopes have different steepnesses. Number 3, the line number 3 has a higher steepness than number 1, as it is more closer to being vertical. And you can see that if you were to calculate the gradient of each of the lines, you can see that the first line is 2 meters per second, and this one is minus 4 meters per second. And as you can see, ignoring the minus, you can see that 4 is greater than 2. So it's going to be 3 is going to have a higher constant negative velocity. And also, if it is negative velocity, it means that it is coming in the direction that it came from. So it's coming this way. It stops. This is number 1. This is number 2. It stays still, and then it comes back the way it came from, which is number 3. The second graph we're going to be going over is a velocity time graph. So I'm going to number it like last time, so number 1, 2, and 3. So you can see that part 1 is a line going upwards, is a straight line going upwards. So if we were to calculate the gradient of the straight line, we would see that it will be velocity divided by time, and that will give us acceleration. So that means that this line will be a constant acceleration. So part 2, which is a horizontal line, you may think that it's stationary, but you can see that the velocity is not changing. So it is still moving, but it's not accelerating or decelerating. So it will be a constant velocity. And part 3, which is a line going downwards, so we use the same formula over here if we were to find the gradient, so velocity over time. But this time, as it is going downwards, it is a constant deceleration. And now, that is not it. As this is a velocity time graph, if we were to calculate the area under the graph, let's say for part 2, we can see that it will be velocity, which is the y-axis, and time, which is the x-axis. And if we were to multiply velocity and time together, you will get distance. So the area under the graph for a velocity time graph, it will be the distance traveled. We're going to be going on to acceleration time graphs. So for this acceleration time graphs, you only need to know the horizontal, number 2, and that is going to be a constant acceleration, as it's still accelerating at 8 meters per second squared, and so it will stay the same. And if we were to calculate the area under the graph, let's say for this time it's under the horizontal section. So if we were to find the area of this area, then we would have to do acceleration multiplied by time, and that will give us velocity. And so the area under the graph for an acceleration time graph is equal to the velocity. So now we have a question, a GCSE example. So we're given a graph, and it states that calculate the acceleration of the train in the 34 seconds. So we can see that there's a line in the graph, and the graph is velocity time. And as it says acceleration, that means that as we're given a velocity time graph, we need to find the gradient of the line. So first we need to find the coordinates of the highest and lowest point. So that will be 34, and the y is going to be 26, and over here it's going to be 0 and 14. So now we have x and y, so we need to find the change in y with the change in x. So that minus 14 and 34 minus 0. And when we do that, we will get, so 26 minus 14, and that over 34. So we will get 0.35 meters per second squared. And that's part I done. So now we need to do part II. And it says calculate the distance the train travels in the 34 seconds. And as it says distance and we're given a velocity time graph, we need to find the area under the graph. So we need to find the area of the whole thing. So as it's in the shape, we can either divide the shape into two parts. So this is part 1 and this is part 2. Or we could just find the area of a trapezium. But whichever is easier for you. I would recommend doing it in two shapes, as it will be easier for you. Just in case you've got how to calculate the area of the just in case you've got how to calculate the area of a trapezium. So you do, so as it's 14 and it's 34, so 34 and 14. So you do 34 multiplied by 14. So that will be 476, and you do half as it's triangled multiplied by 34 multiplied by 26 minus 14, as it's the difference from here to here. And when you do that, you'll get multiplied by 34 multiplied by 26 minus 14, you'll get 204. So when you do that, so you add them together and you will get 680 meters, and there you have it. It is now time for the A-level example, exam style question, where the question is sketch a speed time graph for the motion of the train between two stations P and Q. So if we read the extract, we can see that it says that the train starts from rest at P and moves with constant acceleration until it reaches a maximum speed of 25 meters per second. So we can just label this as part 1, and then we can see that it travels at this constant speed, which is part 2, before finally moving at a constant deceleration until it comes to rest at Q. That is part 3. So I'll draw it over here. So speed and time. Don't forget the units. It's a bit squashed up there, sorry. So for the first part, we can see that it's moving at a constant acceleration. So we can just draw a nice line going upwards. And so as it says that it reaches a maximum speed of 25 meters per second, we can write the top part as 25. And then it says that it travels at this constant speed of 25 meters per second, so we can just draw a horizontal line for that. And then it says that it moves at constant deceleration. But if we read what is below, we can see that the time spent decelerating is 4 times the time spent accelerating. And as it doesn't tell us how long it's spent accelerating and decelerating, we can just label it as t and 40, where t is for accelerating and 40 is for decelerating. So as it is longer to decelerate, we can see that the constant deceleration will be lower. So we can just draw a line with a which is less steep, and we can just label. So label over here as t, which has it is as that's how long it takes to accelerate, and label here as 40, which is from here to here. So this is part 1, this is part 2, and this is part 3. And it also says that the journey from P to Q takes 700 seconds. So we can just mark 700 over here. And that's part A done. Now using this, and using the additional information which says that the distance between the two stations is 15 kilometers, which is 15,000 meters, we need to show that the time spent accelerating by the train is 40 seconds. So with the info over here, we can see that as this is a speed time graph, we can see that the area under the graph will be the distance traveled. So that will be 15,000 meters. So the area of 1, 2, and 3 will be 15,000 meters. So we need to calculate the area for those 3 sections. So for part 1, we can just do a half multiplied by 25 multiplied by t. And that will be 12.5 t. As part 1 is a triangle, so we have to add the half in. So part 2 is, we don't know the time for part 2, but we know that the whole journey is 700 seconds, and part 1 is t and part 3 is 40. So for part 2, we need to do 700 minus t minus 40 to get 2 by itself. So we need to do 25, as that is the max speed, multiplied by 700 minus 5t. And that will be as 4t plus t equals 5t. And that will equal to 17,500. Wait, that isn't that. Wait. I'll just cross that 0 out. 17,500 minus 125t. And for part 3 is, as it is triangle, a half multiplied by 25 multiplied by 4t. And that will be 50t. So if we add all of those together, it all should add up to 15,000 meters. So 17,500 minus 125t plus 50t plus 12.5t, and that will all equal 15,000. So now we need to just get the t's on one side and the non-t's on the other side. So when you do that, we'll get 62.5t equals 2,500, and t will equal to that, and then that will equal to 40 seconds. And that is part B done. So now for part C, we need to find the acceleration in meters per second of the train. So we know that the time taken for the acceleration part to get to 25 meters per second is 40 seconds. So all you need to do is do the speed reached, which is 25 meters per second divided by 40. And when we do that, we will get 40. So we will get 0.625 meters per second squared. So now for part D, we need to find the speed of the train 572 seconds after leaving P. So we know that, so the time over here will be 40. The time over here we don't know yet. And the time over here, so 4 times t will be 200. No, it will be 160. So if we do 700, which is the time taken for the whole journey, so 700, take away the time taken for part 1 and part 3. So we can do 700 take away 40, take away 160, and that will equal to 500. So the time taken for part 2 is 500 seconds. And so as it's asking for 572, we need to add part 1, so that is 40 plus 500, which is 540. And as 540 and 700, between them is 572. We know that 572 will be the part where the train is constantly decelerating, which is somewhere on the graph around here. And the time taken between the start of the deceleration to the time the question is asking for, so we need to do 572 take away 540, and that will equal to 32 seconds. So we know that we know that the time that's gone into the deceleration section is 32 seconds. So we need to do 32 seconds multiplied by the constant deceleration of section 3, but we don't know that yet. So as we know that the deceleration for part 3 is 4 times lower than the acceleration of part 1, we need to do the acceleration of part 1, which is 0.625, we need to do that divided by 4. As it takes 4 times longer to decelerate than the time taken to accelerate. So, and we need to multiply that by 32, as that is the time between 572 and 540. And when we do that, we will get 32 multiplied by 0.625 divided by 4, and that will give us 5 meters per second. So that is the meters per second lost by the deceleration between 540 seconds to 572 seconds. So as we can see that the maximum time before the start of the deceleration is 25 meters per second, we can do the 25 meters per second minus 5 meters per second to get 20 meters per second. And that is the speed at which the train is 572 seconds after leaving P. And that's the answer. It is now time for the A-level example, exam style question, where the question is sketch a speed time graph for the motion of the train between two